Okay, today we're going to talk about key characteristics of quadratics. So remember, a quadratic is going to have an x squared. Okay, it can be in different forms, but you're always looking for that x squared. The graph of a quadratic, this U shape, is called a parabola. Okay, we've talked about some of these before. We've talked about the solutions. Remember, solutions, roots, x-intercepts, and zeros all mean the same thing. Okay? The two we haven't talked about. We haven't talked about the vertex. So the vertex has two options. It can either be the low point or the minimum, the min, or the high point or the maximum, the max. Okay? Then we also need to talk about the axis of symmetry. The axis of symmetry is always going to be a dashed line, and it always goes through the vertex. Okay? So when we are dealing with quadratics, there's three different types of solutions we can have. We're looking at the x-axis, so if it touches one time and goes right back up, that's one solution. If it crosses twice, like in this case, that's two solutions. If it doesn't touch your x-axis at all, that is going to be no solutions. Okay? Recall when we talked about linear, we dealt with domain and range. Same thing with quadratic. So domain is going to be your x values. We go left to right. Remember, two arrows means all real numbers. Okay, range is going to be your y values, and we go bottom to top. Okay, so with quadratics, when you're dealing with range, you're going to have two options. If your quadratic opens up, okay, it's going to be written as an inequality, but not with the variable in the middle. We just need one inequality. So if it opens up, it's going to be y is greater than or equal to the y value of the vertex. If it opens down, so if your vertex is a maximum, it's going to be y is less than or equal to the y value of your vertex. And we'll get more in depth. It'll be a little easier to see on the next slide. So we're going to do some examples. So example 1, the vertex. Go ahead and put a point at the vertex. Okay, we're going to write that value, that xy value. Remember, it's x, then y. So we have -2, +1. Okay. Since it's the top point, it's a maximum. Okay, the function value is going to be the y value of your vertex. So here it's just going to be 1. Okay, so the function value is the y of the vertex. The axis of symmetry. Find your vertex, draw a dashed line. Whatever x value it goes through, it's always going to start x equals. So it goes through -2. Notice these numbers are always going to match. Okay, the solutions, there's two of them. Remember, when we write our solutions, we use our squiggly bracket. So it is -1 and -3, or -3, -1. Okay, the y-intercept is where it crosses the y-axis. So that point would be 0, -3 in this case. Okay, the domain. Imagine that this graph doesn't stop there. It goes on forever. So if we look at the left, we see an arrow. As I go to the right, I see an arrow. 2 arrows means all real numbers. Okay, we set this on the other side, but just so you get a refresher, if it opens down, our range is going to be y is less than or equal to the y of the vertex. Okay, so the y of my vertex is 1, so y is less than or equal to 1. So the value on your range should always match the y value on your vertex. Okay, so next one. All right, so we're going to find our vertex. It is at -3, 0. This time it's the bottom point, so it's a minimum. I'm going to go ahead and label my point x and y. Okay, the function value, remember, is the y of the vertex. So in this case, it's just going to be 0. Axis of symmetry, x equals, and it's the x value of our vertex, so x equals -3. My solutions, this time it only crosses once. Okay, and here's the axis of symmetry. This time I only have one solution, so I can write it. It's just -3. Okay, my y-intercept is off the graph. So we're going to go ahead and skip that one because it would be up here somewhere. So domain. Remember, we have arrows, so 2 arrows, all real numbers. The range. This time, since it opens up, our range is going to be y is greater than or equal to the y of the vertex. So the y of the vertex is 0, so my range is going to be y is greater than or equal to 0. Okay, so when they give you the graphs, you just need to look and identify. Now, if they give you an equation, we can put this equation into Desmos. So we're going to go to Desmos. We have y equals negative parentheses x plus 5, close the parentheses, squared minus 4. So I can't see everything, so I'm going to zoom out a little bit until I can see everything I probably need. So if we look, it gives us a gray point at the vertex. So our vertex is -5, -4. Okay, that graph opened down, okay? So our vertex is a maximum because that's the highest point. Okay, the function value, remember, is the y of the vertex, so -4. The axis of symmetry is x equals the x of your vertex, so -5. The solutions, if we look at this graph, it is never going to cross the x-axis. So there are no solutions. Okay, because I'm going to sketch it over here. It looks like something like that. Okay, the y-intercept. So if we go to the y-axis, there's another gray dot. I click on it. That gives me the y-intercept. So 0, negative 29. I can keep zooming out in Desmos, and it's going to go on forever. So my domain is all real numbers. Notice all the domains have been all real numbers. So that should be a gimme question if it's on a test. Domain for quadratic, all real numbers. Okay, my range, it's opening down. So y is less than or equal to the y value of the vertex. So it's going to be negative 4. Okay? Because all the y values are less than negative 4. All right, let's go to the last one. So we're going to go back to Desmos, clear that out, press the home button to get back to normal. So we have y equals x squared plus 3x minus 10. Okay, I'm going to zoom out. So my vertex is negative 1.5, negative 12.25. And I'm going to go ahead and sketch it. Okay, so my vertex was negative 1.5, negative 12.25. It's a bottom point, so that is a minimum. My function value is the y of the vertex, so negative 12.25. The axis of symmetry, x equals the x of the vertex, so negative 1.5. Okay, if we go back to Desmos, this graph crosses the x-axis twice. So it crosses at negative 5 and positive 2. Okay, if we go back to Desmos again and click on the other gray dot, our y-intercept is 0, negative 10. Our domain is all real numbers. Okay, the range, it's opening up, so y is greater than or equal, because it's going up. So y is greater than or equal to the y value of the vertex, so negative 12.25.